Hello, and welcome to my Pre-Algebra Review Series. This video covers Chapter 9, Section 2, titled Angle Relationships and Parallel Lines. By the end of this video, you will have reviewed your knowledge of adjacent and vertical angles, including finding the measure of an angle. You will also review relating angles and parallel lines. And finally, you will review the aspects of identifying congruent angles. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's get into this one. Okay, let's look at some definitions. Adjacent angles. Adjacent angles share a vertex and a side. Vertical angles. Vertical angles are formed by two intersecting lines and are opposite each other. Vertical angles have the same measure. Congruent angles. Angles that have the same measure are congruent angles. Supplementary angles. If the sum of the measurement of two angles is 180 degrees, the angles are supplementary angles. Complementary angles. If the sum of two angles is 90 degrees, the angles are complementary angles. A transversal, a line that transects two other lines in different points, is a transversal. Some pairs of angles formed by a transversal and two lines have special names. Corresponding angles. Corresponding angles lie on the same side of the transversal and in corresponding positions. Alternate interior angles. Alternate interior angles are in the interior of a pair of lines on the opposite sides of the transversal. Objective 1A, adjacent and vertical angles. In this review, you'll be revisiting the skills needed to identify special pairs of angles. Adjacent angles share a vertex on a side, but no points in their interior. So here we see angle AXB and BXC. The two angles share a common side, which is XB. So angle AXB and BXC are adjacent angles. But AXC and BXC are not adjacent. Okay, objective 1B, adjacent and vertical angles. Vertical angles are formed by two intersecting lines that are opposite each other. Vertical angles have the same measure. So as we see here, it says angle 1 and 3 are vertical angles. You see angle 1 is right in here, and 3 is over here on this side. They are opposite. When you look at these two intersecting lines, 1 and 3 are opposite, 2 and 4 are opposite. So that's how you spot these vertical angles. Objective 1C, still adjacent and vertical angles. Angles that have the same measure are congruent. So using the same picture from the previous slide, we can see it says angle 1 is congruent, right here. Angle 1 is congruent to angle 3. So we said that they were equal. Remember that in the previous slide? 1 and 3 are equal because they're opposite. They're vertical angles. Okay. You can write it as angle 1 is congruent, and this is the congruent symbol right here that we're using. It's an equal sign with a little wiggly line on top. I'll do it again. Maybe I can draw it this way better. How's that? Like that, I guess. That's the best way to draw it. See? Yeah, I think I would do it like that. It's kind of, you have to get used to drawing it. You can write the measure of angle 1 as M angle 1. This stands for the measure. When you see the M in front of the angle sign, it means the measure of the angle. The measure, 25, 35 degrees, 15 degrees, 90 degrees, the measure of the angle. And since angle 1 is congruent to angle 3, the measure of angle 1 is congruent with the measure of angle 3. Okay, objective 1D. It's all the same objective. I've just added these letters for each slide. Adjacent and vertical angles. If the sum of the measurement of the two angles is 180 degrees, the angles are supplementary. So here's where we get it. You see down here in this example here, there's this line AD and a ray coming off at point B right here. Well, this forms an angle. This ray coming off of AD forms an angle, and the angle is 120 degrees. Well, the angle over here on this side, the sum of this 120 degrees and whatever this angle here, this question mark is here, okay, is 180 degrees. That's what they're saying. And they are supplemental. Okay, for objective 1E, adjacent and vertical angles, we're still talking about supplementary angles, but we're going to add in complementary angles here right away here in this same slide. So if the sum of the measurement of two angles is 180 degrees, the angles are supplementary. So we look down at the first square here, the first picture. It says angle ABC right here. Where's my pencil? There it is. ABC, that's right, this angle here is 120 degrees. CBD is whatever the remainder is, equaling 180 degrees. So this is going to be 60 degrees over here. Okay, 60 degrees. 60, close that 0. Okay, so now they're showing you that X is a 60 degree angle, and you can see that it looks similar to it. Okay, so it says ABC and CBD are supplementary, and it says angle X and QRS are complementary. So let's go over and look at the other picture here. It says angle PQR right here is and RQS are complementary. Well, here's RQS right here, and they're saying that RQS is 30 degrees. Well, if that's equal to 30 degrees, then what's remaining here is 60 degrees, because if the sum of two angles, or the measure of two angles, is 90 degrees, they're complementary. Well, this statement down here that we looked at earlier, it says angle X. So now this angle is separate from this other diagram. Angle X over here in this picture and RQS in this picture, they're relating them, and they're saying that those two angles are complementary. Example 1, find the measure of an angle. In the diagram, find the measure of angle 1 if the measure of angle 4 is 135 degrees. Well, based on that, we're going to add and look for the measure of angle 1 right here. Angle 1, the measure of angle 1 plus the measure of angle 2, or angle 4 rather, has to be equal to what? Okay? It's 4 is right here along this straight line. They're on the same side of the line. That's okay. So they are supplementary. 1 and 4, if you take the two of those in total and you add them up, that's 180 degrees. Okay? So it's 180 degrees. So if the sum of the two of them is 180 degrees and 4 is 135 degrees, okay, so then we can rewrite that. We can say right here, the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. Then if we replace angle 4 with 135, then we're going to say that the measure of angle 1 plus 135 degrees is equal to 180 degrees. So now we know we're going to look for this measure of angle 1. We're going to move 135 to this typical algebra on this. So the measure of angle 1 plus 135 minus 135 is equal to 180 minus 135 degrees. I'll put the degrees in. Okay, so now we have the measure of angle 1 is equal to 180 degrees minus 135 degrees. So the measure of angle 1 is equal to 45 degrees. Okay, and that's what they're asking for here. Okay, example 1, check your understanding. So why don't you take a look at this. It says if measure of angle 8 is 20 degrees, find the measures of angle 5, 6, and 7. So why don't you stop the video and try this out and come on back. When you're done, we'll work it out. Okay, now that you've completed that task, let's take a look at it. We know that the measure of angle 8 is 20 degrees. And we see where angle 8 is over in the picture. Angle 8 is right here. Okay, this is angle 8. Okay, so we know a couple of things. We know that the angle 6 right here is a vertical angle with angle 8. And we were also told earlier that vertical angles are congruent, that they're equal. So we know that if angle 8 is 20 degrees, then angle 6 is equal to 20 degrees. We could do it another way too, but by a longer way, but this is quick. Okay, so now if we know that we want to find, let's say, angle 5. Here's angle 5. It goes from right here up this path right up here. Well, we can do one of two things. We can say angle 5 is this angle from here to here. Okay, is 180 minus the 20 from the 6 or minus the 20 from the 8. It doesn't really matter. We can do this line down here. I'll pick a different color. We could do this line here as our choice. Okay, and to come up with the supplementary angle. So if this is 20 degrees, 8 or 6 are 20 degrees. 5 is going to end up being 160 degrees. So it's going to be 160 degrees. Okay, and for the same reason, 5 is a vertical angle to 7, would make it 160 degrees. Or you could do it again, you could take angle 5, we want angle 7 along this line here. We know that this is angle 7 and 6 are 20. 6 is 20, so 180 minus 20 is 160. So there's our angles. Okay, objective 2, relating angles and parallel lines. A line that intersects two other lines in different points is the transversal. Some pairs of angles formed by transversals and two lines have special names. So we're going to look at the names of those angles that are formed. Corresponding angles lie on the same side of a transversal and in corresponding positions. So this is the transversal. We're going to go from here. We're going to call this the transversal here, this line through here. This line is intersecting two other lines. So it says corresponding angles lie on the same side in the same position. So a corresponding angle would be this angle here. On the same side, it would be angle 2 and angle 6. Corresponding angles. So 1 and 5. Here's 1 and 5. Okay. And 3 and 7. 3 and 7, 2 and 6, I already picked off 2 and 6, and 4 and 8, which are these 4 and 8 along here, okay? That's it. Our corresponding angles. Alternate interior angles, I'm going to do them in red. Alternate interior angles are angles that are between the two lines that are being intersected. Okay, so it says alternate interior angles are in the interior of a pair of lines and on opposite sides of a transversal. So angle 3 and 6, 3, here's 3, and 6. Okay, and 4, here's 4 right here, 4, and 5. So 4 and 5, these guys, and 3 and 6. Those are alternate interior angles. They're alternate because they're on opposite sides of the transversal. interior because they're between the two lines in the transversal, and they're on opposite sides of the transversal. Example 2, identifying congruent angles. In the diagram, L is parallel to M. Identify each of the following. Okay. L, this is L according to my notes over here. L is not the same character, but here, L and M. Okay. So these are the two parallel lines, L and M. And our transversal is right here going through. It's a line transversing. Okay, so it says congruent corresponding angles. So what are congruent corresponding angles? Well, the corresponding angle is if you take the two parallel lines in the transversal, they're on the same side of the transversal. Like 1 and 3, 2 and 4 are on the same side of the, and 8 and 7 are on the other side of the transversal. 1 and 2, okay, they're supplementary angles. We know that because here we have a straight line here and an angle, and 1 and 2 are supplementary, so they're 180 degrees, but that's neither here nor there. I'm just making the point. They want to know congruent corresponding angles. Well, corresponding means if I pick angle 1 over here, angle 1, a corresponding angle in this diagram would be this angle 3. You see how it's the same angle? It's corresponding in the same position relative to the parallel line. The other corresponding angle would be 2 and 4. 2 and 4 would be corresponding. So let's see. Angle 1 is congruent to angle 3. Congruent corresponding angles. These angles are congruent. 2 and 4. 2 and 4. Angle 2 is congruent to angle 4. Okay, that's these right here. And if you go on the bottom side, I'm going to change colors, go red, 8 is corresponding to 6. Well, in this consideration with parallel lines and a transversal, they are congruent. So we have angle 8 is congruent with angle 6. And then finally, angle 7, right here, is congruent to angle 5, right here. Okay? How about congruent alternate interior angles? Well, when they speak of interior angles, they mean the angles between these two parallel lines. The angles in between. So 2, 3, 6, and 7 are interior angles relative to the transversal that's drawn here. Okay? So congruent alternate interior. So which angles are congruent based on these two parallel lines in this transversal? What they're saying, let me pick a different color here. I'll pick orange. 3 is an alternate angle to that. Interior is 7. Okay? 3 and 6 are supplementary. They're not congruent. We know they're not the same unless that was a 90-degree angle. They're different. But 3 and 7 are congruent. So in our case, angle 3 is congruent with angle 7. Okay? And angle 6 is congruent to angle 2. So angle 6 is congruent to angle 2. Okay? Example 2, check your understanding directions in the diagram. A is parallel to B. Name 4 pairs of congruent corresponding angles and 2 pairs of congruent alternate angles. Okay, stop the video and try it yourself. When you come back, we'll continue together. Okay, as it said in the diagram, A and B are parallel. Name 4 pairs of congruent corresponding angles, 2 pairs of congruent alternate angles. 4 pairs of congruent corresponding angles. Let's start with angle 1. Angle 1, right here, is congruent with angle 5. And how do we know that these are congruent corresponding angles? Well, corresponding angles, if you look at the two parallel lines, A and B, they're both on the top side top side of the lines in this particular diagram. They're on the same side relative to each other. In this case, the top side. And they're on the left side of the transversal. I'll call that the left side, as opposed to the right side. So they are congruent, corresponding. So angle 1 is congruent to angle 5. The next, angle 4, is congruent to angle A. Angle 4 is congruent to angle 8. Now, angle 7, right here, and angle 3. They are now on the bottom side of the line on the right-hand side of the transversal. Okay, so 7 and 3. Angle 7 is congruent to angle 3. And finally, angle 2 is congruent to angle 6. Angle 2 is congruent to angle 6. Now, two pairs of congruent alternate angles. Well, I'll switch to red this time. Okay, so now alternate, there would be interior angles we'll go with, I guess. So I'm going to go with interior angles are angles that are in between okay. So we're going to go ahead with, I'm going to pick 4 and 6. They are across the transversal, alternate. That's what the alternate means, alternate sides. And they're interior because they're between the parallel lines. Okay? So we're going to say angle 4 is congruent. Oops, drew that wrong. Is congruent to angle 6. And angle, what's another one here? How about 5 and 3? Angle 3 is congruent to angle 5. So, and I have a little note down here on the bottom. It says, when solving a problem that involves parallel lines, you can often choose whether to use corresponding angles or alternate interior angles. Kind of, you can play that game, okay? Whatever makes most sense. Depends on what information you have. Makes it easier to solve your problem.